Hello guys, AP Stats. This is Mr. Kim. And I know that you had several, like review sheets that I passed out to you guys. So my goal is for you guys to not only get the answers right, but also understand the process behind these. So this will be my first video officially made to you guys, and I'm hoping that this video helps in helping you guys understand like where these answers are coming from and things like that. So if you can see from the shared screen here, I have the answer key for the reviews, and I just want you to go along this with me. So let me go over the first question here. It says a set of test scores has the following 5-number summary. We have basically a box and whisker plot. Which statement about outliers must be true? Now, remember the rule for IQR times 1.5, that really determines your outlier, whether it's going to be one or not. So it seems like IQR here is 28.5 minus 18, which is 10.5. And if you multiply that by 1.5, I believe, I don't have the calculator with me, but it will be like what, 5.25 plus 10.5. So it will be 15.75. So we are basically adding and subtracting about that much from quarter one or quarter three. Once we do that, we have, I think, an outlier here where minimum is 2. So that if you subtract 18 minus 15.5, you actually get 2.25. 2 minimum value is actually lower than the minimum boundary like a cutoff line for the outliers. Therefore, number 2, this minimum is going to be an outlier versus this maximum 33. Well, the cutoff for the boundary for that would be 28.5 plus 15.75, which would be like what, like 44.25-ish or so, I believe. So I think that is the reason why this is not going to be considered an outlier here. So yes, there's only one outlier on the lower end section. This is the question I went over with you guys during class, I believe, for maybe, I think, 8th period. But basically what you guys want to remember is that for box and whisker plots like this, every single one of these things, like for example, minimum, quarter one, median, quarter three, and max, they each represent like 25% of the data set, because this median, this represents 50% of the data, like exactly halfway through. But quarter one actually cuts that into 2. So this represents 25% of the data set. Like if there were 100 data points, there will be 25 and 25 and 25 and 25 like that. Okay, so that's what I need you guys to get your head around. I know that this is not something I taught to you guys during the class. The textbooks didn't have them, and it's something that the AP prep books have, but it kind of makes sense. It's kind of implied that the median is 50%, and I guess they expect you to know that. So for these types of questions, like, you have to painstakingly read through all of this, and I would suggest process of elimination will be the best type of scenario for this, because you want to make sure that you didn't miss out on all of these multiple choice. So let's go over these one by one. The number of serials with HFCS is about the same as the number of serials without HFCS. We're talking about the numbers here. I have no clue as to how many dots are actually within each of those like, here or here. Like there's no numbered dots. Like it's not a dot plot. I don't know what number of serials there are. A is just straight out wrong because it's not a dot plot or a histogram. You can't tell me the number of the samples from the box and whisker plots. So box plots, you can't tell the sample size or sample number. The serials with HFCS have a greater interquartile range than serials without HFCS. So you can actually figure that on your own. I mean, if this is like 13 minus 6, so this gives me interquartile range of 7. That's 4 and that's 12, so that gives me 8. So no HFCS gives me a higher interquartile range. So therefore, HFCS have a greater interquartile range is completely the opposite of what I'm trying to say. The serial without HFCS have a greater range than the serials with HFCS. Okay, so the range is lowest minus the highest. So that will be, I'll use a different color to annotate that. So that's blue, 0 to, what is that, 15-ish. So that's 15 in range, versus 2 to 20, which is 18 in range. It seems like HFCS clearly is the victor here. So series without HFCS have a greater range makes no sense. So C is also out. So now we're really down to D and E here. So now with these two, about half the series without HFCS have less sugar than about 3/4 of the cereal with HFCS. Now, what in the world does this mean? Remember what I told you about this 50, 25% of the data set, for the box and whisker plot? What they're basically saying is that half of the cereals without HFCS have less sugar than about 3/4 of the cereals with HFCS. Let's take the highest 3/4. That is three of the 4/4. So it pretty much represents 75% of the highest possible sugar content within HFCS. Half of the cereals without HFCS have less sugar. Let's take a look at the half of the lower section of the HFCS. So we're comparing those two. So this represents 75% of the data of the HFCS sugar content versus this has 50% of the data of the sugar of the cereals without the no HFCS content, basically. So when you compare these, notice how they kind of overlap here, in the middle here. So when we say about half the cereals without HFCS have less sugar, that's not true, because there's some content in some cereals that have the same amount of sugar for the highest HFCS content at 3/4. So this is not going to be true. So the process of elimination tells us that it's definitely going to be E here. About half the cereals with HFCS have more sugar than about 3/4 of the cereals without HFCS. So let's take a look at what this is talking about again. We are taking a look at about half the cereals with HFCS. So that is with HFCS means highest sugar content with 50%. So about half of that have more sugar than about 3/4 of the cereal. Now remember, 3/4 of the cereal means basically you're going from like the minimum, Q1, median, and Q3, because that's 25, 1/4, 2/4, and 3/4. Look at where Q3 lands and where that lands located with the median section. So here, what we can tell is that, about 75% of all the cereals without the HFCS has less sugar, because it's clearly less. There's no overlap, as you can see. It's clearly, they line up exactly where they need to be. These 50% of this cereal with sugar content, they have more sugar. Therefore, this is definitely going to be true. I want you guys to think of it in that sense, and I'm hoping that this really clarifies question number 9. For 27, we have a spreadsheet contains a data set that consists of 100 values, such as IQR is greater than variance. A lot of students ask me about this. You can pretty much ignore this at this point, because IQR greater than variance is pretty much telling you like I is equal to square root of -1, like SAT questions. Like they're just telling you that for statement of fact. It doesn't really have anything to do with whether you can solve this question or whether you can understand the question. You really want to start from reading from here. However, these values must be converted using the following formula. New value equals 2 times old value plus 10. Notice how I don't even count the plus 10s here, because when you add or subtract numbers to the data set, it's not going to do a thing to the IQR. So for example, let's say I give you a data set of 3, 1, 2, 3, 4, 5 versus 8, 9, 10, 11, 12. So that lowest and the maximum, each of them got added by 7. Median will also get added by 7. Q1 and Q3 will also get added by 7. If you find the difference between these two, like 2 and 4, 9 and 11, the difference of this is 2, difference of this is 2. IQR doesn't change just because you add a bunch of numbers into the data set. So that is complete rubbish. You don't even need to consider it, which means, so to sum up, when you multiply like this, like multiply a number to the old value, that actually impacts the IQR. You can also check that yourself. 1, 2, 3, 4, 5 versus 2, 4, 6, 8, 10. Your interquartile range has now changed into a 4. So it's now increased. So the IQR is now doubled its previous size. That's the only way that you're going to change the IQR. Standard deviation is when you multiply. So if you want to write yourself a little note here, I'm going to find a little space. Like when you multiply the numbers, in the data set, basically all those things changes, like the mean changes, median changes, the standard deviation changes, as well as the IQR change. When you add or subtract, only median and the mean change. That's what I need you to remember. So the multiplication is the key that changes the IQR and the standard deviation. Please remember that when you're doing this question next time. Next, teacher promises bonus points to students with exam scores greater than the mean exam score for all students. Which of the following distribution exam scores is most likely to result in the greatest percent of students receiving the bonus points? Okay, so we are talking about exam scores greater than the mean exam scores. So what that means is, if we want to have more people taking that, let's take a look at the examples of the multiple choice to help us out here. A uniform distribution of all the students, which would mean that the mean is somewhat equal to the median of all the people. About 50% of all of those guys will be getting this extra credit. Okay, fair enough. A roughly normal distribution of exam scores among all the students. That's pretty much the same thing as saying B. So that's kind of like grouped together, which doesn't give me a clear sign as to which one is going to be the correct answer, but we'll just leave it for now. A symmetric but not bell-shaped distribution of exam scores among all students. Again, A, B, C are pretty much talking about the same thing. Usually it's a street smart way of solving questions. Like the one with skewed to the left or skewed to the right, the only like one word of difference between two choices. Usually in most multiple choice questions, one of these will always bound to be the correct answer. And yes, indeed it's D. Why skewed left distribution? Well, because if you think about it, there are going to be a couple of outliers towards the left-hand side, or maybe there could be none, but it pulls the mean towards this side, because if it's skewed to the left, it's going to pull the mean this side, where the median, okay, the median will be greater than the mean. That was 50% of the data versus and plus a little extra. You see, so we're talking about as many people as possible getting the extra credit. This gives me 50% plus. We get more people to receive that extra credit because more than half of you guys will be getting more than the mean score, more than the average score. So it's definitely going to be D. Which of the following is the most reasonable statement above? Most of the yearly returns are negative 10,4. So here, I know that some students might have struggled with this as well. Let me just go over this with you briefly. The mean and the median for yearly returns are roughly equal. That's clearly not true because this, as you can see, is a skew to the right distribution. So therefore, you are not going to see the mean and the median to be the same thing. Only you get that when you're roughly symmetrical, okay? Median is greater than the mean. Well, median is greater than the mean means that the mean is actually pulled this way, like for example, like answer choice D from the previous question. But the problem with that is that, you know, it's not going to be the same thing as before. My screen froze, I think. Oh, there we go. Now it's working. So first of all, going back to this, median is greater than the mean. We're talking about like answer choice D from the previous question, where it has to be skewed to the left in order for B to happen. So B is not going to be true because this is skewed to the left. The right and left whiskers contain the same number of values. I can't tell how many numbers there are, but so the left and the right whiskers contain the same number of values. Well, they both represent 25% of the data, but the problem here is that there are 3 outliers here. These 3 outliers means that 3 data sets from this entire thing would represent 25% of the data point, not just this whisker right here. Okay, so giving you an example, if this left whisker contained 10 data points, this right whisker will only contain 7 data points because there's 1, 2, 3 data points after that, which makes it 10. So that's what makes it 25 on either end, and IQR is the 50% of the data set. So therefore, C is not going to be true. Most of the yearly returns are in the 4,30 interval. Okay, so let me go to where 4,30 is. So where is 4? So every increment is 2. So 4 is right here and 30 is all the way over here. It seems to me that this right here, because it's below the median, it's above the median. If I were to shade this part in, this is less than 50% of the data because from median all the way to the outlier, all the way to the outlier, that will represent 50%. But you can clearly see that there's a little gap. So that would make it less than 50%. So here, if we go from -10 to actually +4 here, that represents more than 50% of the data. So most of the yearly returns are from that. That seems like the most reasonable statement from that. Okay. when we say most yearly returns, but it's barely less than 50%, I mean, how can that be true, right? So again, it's kind of like a process of elimination question once again. The student council at high school surveys students about a variety of questions. Which of the following displays would be appropriate to display the number of males and females in each grade who plan to attend prom? All right, so here we are comparing the males and females in each grade. So for example, let's say we have 9, 10, 11, and 12. We want to compare males and females. So if we're talking about any of these things, histogram, dot plot, and box plot, all of these measures one quantity, like one measure of categorical variable. So supposedly, let's say I want to find out all the males who wanted to find out surveyed varieties of questions. This will appropriate display the number of males and females in each grade who attended prom, who plans to attend the prom, basically. So let's say that I try to do this with like a histogram or a dot plot or a box plot. I wouldn't know how you would go on about that, because you're basically finding out the number of people for, let's say, ninth graders. So it's a bar graph, basically. It's not, it's kind of like a frequency amongst like the freshmen, the sophomores, the juniors, and the seniors. But then for these to be represented on, let's say, a histogram per se, this right here, it has to, like on the x-axis, it needs to be a quantitative variable. Like it's gonna be like height, years, or whatever that they're measuring by. And the dot, it really measures only one categorical thing. Histogram, dot plot, and box plot really doesn't do much. And besides, the scatter plot is measuring like the dots, and it's like x comma y. So like you're a freshman and he plans to attend 10 prom. Well, this particular point, 9 comma 10, like what does that represent? A freshman that goes that represents 10. It's much better if you just, because we're comparing males to females, a side-by-side bar chart, quite honestly, out of these 5 choices, that's the lesser of all the evils. So we will see females here, females here, females here, and then you guys get the idea. So when you're trying to compare the two categorical things, always make sure to use side by side or segmented to see what we're dealing with here. If you see the posters around my room, they all have different categories, like that represents each of the segmented bar graphs. Okay. Victoria is working for an advertising company that has analyzed the amount of engagement on social media influencers. She randomly selects 80 posts that the target audience might view. For each post, she finds the number of people who actively engage with the post, then computes the average. The sampling distribution of this average will be approximately normal because the sample size is large. Now, again, these are just going over the ends like this. There's no math to be involved. You just have to painstakingly read all this and pick out the one that makes the most sense to you. Okay. Ooh, my fault. Let's go back to the question here. Okay. So approximately normal because averages are always normal. What does it mean that averages are normal? Out, like right away. That makes no sense. The averages are always normal. We always tend to avoid the word always in statistics. We want to say like approximately, and its tendency to do this or tendency to do that. Statistics never reveals anything about like cause and effect. We always want to say that it might likely that something like happens. So A is just straight up a no. Approximately normal because the standard deviation of the sampling distribution has a small value. Okay, first of all, what we're trying to target here, she randomly selects 80 posts that the target audience might view. For each post, she finds the number of people who actively engage with the post, then computes the average. So that could be like comments or how many likes that the post gets. How does it know that it's going to have a small value of a standard deviation? Well, let's say that there is not very much of a standard deviation. Okay, we can have normal distribution that is not roughly normal, that doesn't really have the standard deviation to be very, very small. I think C could, if I were to actually be taking this test, I would leave C alone and I would really debate between, let's say, B or C, but let's just leave C for now. Let's go over D and E. Skewed to the right because the population is skewed to the right. The population is just the number of people, and we randomly select 80 posts that the target audience might view. If you think about this in the real world statistics, we don't see a lot of people with high number of posts and only few people with low number of posts. There are a few very high, influencers. Okay, so analyze the amount of engagement on social media influencers. There might be a high number of people who actually views this. This is actually a little bit tricky. Skewed left because social media influencers can't have low numbers of engagement. Sampling distribution of this average will be. This is actually quite tricky. I actually don't quite understand how it could be B, because that's what the answer key said. Because the sample size is large. I might have to double check with you guys on this one, but I don't really understand why it's supposed to be B, because 80 is not actually, it's large, but not, it could be larger. Skewed to the right because the population is certainly skewed to the right. That doesn't sound as bad. That sounds worse than answer choice E. Actually, skewed to the left because social media influencers can't have low number of engagements. Well, actually, they're contradictory statements, so E is actually not going to be true. But really, amongst these guys, approximately normal because the standard deviation of sampling distribution has a small value. I think it's because C cannot be determined. You don't know how many, like whether it's going to be small or large. If we're actually talking about the one that's the best one, I can go with the B here. We can't calculate the standard deviation because we just don't know how many engagement measurement, like likes and comments there are. So this is just too ambiguous for me. Population is certainly skewed to the right. I personally like D here. But for 6, I'll just get back to you guys on this one. This is a little tricky. I would really debate between B and D for this. Anyways, let's move on. Sorry about that. Which of the following is the greatest? For this one, the answer is impossible to determine without additional information, because if you read all the rest, they're pretty much rubbish statements. The number of first of all, you can't tell me the number of people because it only tells me percentages. Like how many actual total people of high school dropouts do we have? We don't know that. So right away, you can just eliminate A, B, and C. The above are all equal. That's the worst of them all because you don't even know all these. So this was probably the easiest question. 25 college. Okay, by the way, we're not actually doing this question because this is actually not for this chapter. There's something called a p-test value of p less than 0.05 or p is greater than 0.05 to actually determine whether the statement is unlikely to have occurred by chance. There are a couple of determining factors. There's the thing I say is a magic number 5% rule. So as long as you can find out the fact that, because 4 or more occurred in 13% of the trials, that's actually higher than 5%. That's why it's going to be a no. Of course, I didn't teach you this, and this is not part of the exam, so please omit this. You don't have to worry about this question. Dan earned $75 a day. This put him on the 85th percentile. Suppose all teenagers are given $5 salary increase. All the teenagers were given that. So every number in the data set gets increased by $5. Does that do anything to the percentile? No, because 1, 2, 3, 4, 5, then you increase it by $5, 6, 7, 8, 9, 10. You're the 80th percentile here. You're still the 80th percentile in the new data set. So it's still 85th percent. Okay. If that's too theoretical, supposedly, let's say, like, for example, like you're lined up in a line, like, so you're here and there's like 5 friends of you guys, just lined up that way. And then each of you guys take 5 steps forward. So you basically go 5 steps forward like this. Okay. In the position that you're at, like you're still the second place amongst the group from before and now after. So your percentile still does not change. Percentile means like the position. Like if you're the 90th percentile of the group, that means like you're at the top 10%. Like you're at if there are 100 people, you will be at the position number 90 from this way. So you're like the high top 90. In a set of not 5 numbers, the smallest increased by 10. So we're talking about 5 numbers. So the smallest is increased by 10, the largest increased by 15. Overall, they increased by 25, but the average, you got to divide that by 5 by the total number. So it increased overall by 5 for the average. Okay, so for female and male, I think we can see the distributions here. Male is roughly symmetrical and female has skewed to the left, I believe, because this is a smaller number set. So female sample has a greater range. Obviously, we can figure that out. So supposedly for females is 61. highest is 75. For males is 66, and the highest is 81. The difference is 15, the difference is 14. Therefore, this is not going to be true. The female sample has both greater standard deviation and the greater range. Well, because it has a greater range, that just really gives it away. Sample has both greater standard deviation and the greater range. Guys, standard deviation is the measurement of spread. Like you can see that for females, like overall the spread, because it's skewed to the left and you want to contain that value, versus male where it's like really narrow and like very congested, centered around the 70s right here. So the standard deviation among the males would definitely be smaller compared to standard deviation of the females. That's, you got to just take a look at the shape and you can already tell me that. The two samples have rough, nope, they don't have equal ranges. I mean, that just eliminates 3 choices right away. The female sample has a greater standard deviation because it's more spread out, while the male has a greater range. Absolutely true. This was the open-ended question. I just, rather than me writing it and giving you a very bad handwriting, like trying to read my handwriting, I'd rather just have it typed. So here I asked you to describe the distribution. Remember socks, please. It's roughly skewed to the right, as you can see. I think I said that here. The shape is somewhat skewed to the right. So somewhat is the word because it's kind of, it's roughly like somewhat, they mean the same thing. And there does not appear to be any outliers. Based on the histogram, the medians are around between 12 to 13. So pretty much here and here. Why is it here? Well, cross out the numbers from each end and you will see that it's between those two numbers. The IQR spread is between 10 to 11 and 14 to 15. You can also do that by yourself. Or the spread of the data is between 8 to 9 to 19 to 20. What that means is that when you guys are talking about spread to me, you can mention 2 things. Either you mention IQR and you get full credit, or it's a choice, or you can mention the range. Well, not the range, but you guys know what I mean. Minimum to the maximum, that also measures the spread. You can always mention those 2 things to me and you will get credit for that. So shape is mentioned, outlier is mentioned, spread is mentioned, the center is also mentioned, right? This median is between 12 to 13, which is the median right there. Again, describe the distribution. Now I'm giving to you in a more of a box and whisker plot setting. The distribution of data has a center of median of 37 with the IQR of 14. If you mention the data has spread from 20 to 29, it will be more correct because that's the spread of the entire data. 1.5 times the IQR is 21, adding 21 to Q3 yields 66. Subtracting 21 from Q1 yields 10. So what in the world am I talking about here? Well, Q1 and Q3 are 31 and 45. The difference between them is exactly, I believe, 14. Multiply that by 1.5, you get 21. So you want to add 21 and subtract 21. This gives me 10. This gives me 67. Now, anything beyond those 2 categories, two boundaries, is considered an outlier, which clearly the max, which is bigger than 67, and the min, oh, actually, that's within the boundary, so that's fine. So you don't have to worry about that. So max is the only one that's the outlier here. So because 75 is greater than 66, that is considered an outlier. There are no values less than 10, therefore there are no outliers on the left. In addition, because there are, I forgot to mention a couple of things more to you here. I'm sorry. So let's just kind of go over this. So we have the center check. We have the spread check. We did the outlier check. So shape, say a shape, outlier, center, spread. I believe it said in addition, because there I believe this is a box and whisker plot kind of setting, there is no way for us to tell the distribution of the shape, but because we have an outlier on the right, in addition, because there is an outlier on the right, it is roughly skewed to the right. Okay, or somewhat skewed to the right. I mean, we can kind of assume that whenever we have an outlier towards an either end of the spectrum, because that will give me a little bit of a tail towards that end. So yes, you can definitely say that. If you said that the shape is not cannot be determined from this data set, I'm not sure, because we do have a clear outlier, so it's much more appropriate for you to say skewed to the right for the shape. Again, mention socks all the time. Which of the following is true? The range of wait times for this group customers is 16. Indeed, 22 minus 66. 22 minus 6, I'm sorry. The mean wait time for these customers is 14. Nope, you can't tell me the mean because I don't know how many number in the data set there are. About 50% of the time, the customers waited 14 minutes or more. Remember, that's the median. This represents 50% of the data. So 50% waited more than 14. Absolutely true. The distribution of wait times for this group customer is symmetric. I can't tell that. You can't tell me the shape from the box and whisker plot. So the shape is not in the shape is indeterminable. Therefore, it's going to be false for the last statement. This is a very simple question. I mean, you just have to find the median of this. So you cross out the bar here. There are two numbers here, so I'll cross out one number here, cross out one number. So I crossed out three numbers and three numbers from the either end. If you're ever wondering what I'm doing, just look at the frequency on the left-hand side. I have one, like each of these little boxes represents like one number. So I cross out three boxes and I cross out three boxes on the left and the right-hand side. And I just keep on doing that. This will cross evenly with that. That will cross evenly with that. This and this will cross out, and this part can cross out. So you can clearly see that this one part here that actually resembles 98.25, that's where the median should be, or 98.2. Okay. All right, so now we're down to the open-ended questions and one more multiple choice, so we're almost there. Again, I gave you the typed version of it. So describe the 5-number summary. If you remember this, this is the 2021 AP FRQ for the first question. This is the dot plots. You can see that we have two outliers here, skewed to the right. You can, if I tell you for the socks, we've already done that, right? 5-number summary is as follows: 5, 6, 7, 8, 21. Well, how did the world would you be able to get that? Use your darn calculator. Type all these numbers in. It's not that bad. There's only like what, 14 numbers in there. Type it all in, get your summary statistics, and voila, you're done. Okay. Consider the two rules. Okay. There's the 2 standard deviation rule, which we didn't go over. So I just want you to use method A for now and determine it. So here it's very simple. Determine any data points that are potential outliers. Do what the question tells you to do for FRQs. The patients who stay for 12 days and 21 days are considered to be outliers using method A. Notice how usually in FRQ, this is straight from the answer key. They usually open up with a sentence that's very straightforward, very concise, very on point. Like they already tell you the answer right away. Then you want to dig a little deeper and tell me why. An outlier using method A is a value greater than 1.5 times IQR. So IQR here is clearly 2. You can tell me that. So that's 2 times 1.5, which is 3. You can tell me the process of the math as well. Because quarter 1 minus 1.5 is 6 minus 3, which is 3, then any values below 3 are considered to be outliers. There are no such values, correct? Because quarter 3 plus 1.5 times IQR, that's 8 plus 3, which is 11, then any values above 11 is considered an outlier, which we certainly do have as 21, as well as 12. So we can say that 12 and 21 days are considered an outliers. I will just add it with therefore, 12 and 21 days are considered an outlier. Considered outliers as outliers. Okay. All right. So another the open-ended question. So here's the answer key for that. So the maximum yield for the treated acres was 51.5 bushels of soybeans. Okay. So we have this. Is this an unusually high yield compared to the other treated acres? Is this an unusually high yield? What they're basically asking for is this the outlier from the norm? That's what they're asking. Again, quarter 1, quarter 3, we're going to say the same thing. The 1.5 times IQR guideline can be used. They do it in a little bit of a different manner, but we can say right away, just like this sentence, because I really love how they phrase this one. So you can just find out the answer right away, but we say the IQR, you can find the process of it. So we are talking about 1.5 times IQR, which is 8.91. So we're going to subtract 8.91 from here, add 8.91 from there. Clearly, maximum is within it. Minimum is also within it. I think it just means that the maximum is 51.5, and the non-outlier would be 55.37. So here we have the fact that 51.5 is within 55.37 of 51.5, I mean. So that's why there's no outlier in that direction. And I don't believe there's an outlier in the below the quarter 1 direction as well. It would be acceptable to use the mean plus 2 standard deviations. We haven't talked about this as of yet because we didn't really dive deeper into standard deviations. We'll do that in the next chapter though. So please ignore this for now. Even if the treatment, oh, I'm sorry. Let's read the question first. Researchers indicate that the average yield for treatment group is statistically significantly higher than that of the control group. So the average yield for treatment group. Explain what this means in simple terms. All right, so this one might be a little tricky because I really haven't gone over this type of question with you. Researchers indicate that the average yield for the treatment group is statistically significantly higher. We're talking about the average here, so my eyes immediately go to the mean. Okay. Explain what this means in simple terms. So treatment group has a mean of 43.5 and control group has a mean of 35.813. And we're talking about, maybe you want to read the context a little bit more. So we say that some plants react with reduced biological nitrogen fixation, hindering their ability to grow at a typical rate, or working to develop techniques to supplement crops so that BNF rate is not as greatly reduced during the drought. One promising treatment to be compared to standard growing conditions on randomly selected acres of soybean. So we did treatment and we do control. Treatment means you apply, I think, this reduced biological nitrogen fixation, BNF, while the other one you don't, and you're comparing them. So so researchers indicate the average yield for treatment group is statistically significantly higher than that of the control group. Even if the treatment has no effect on the soybean yield, the means of the group will probably be different due to random variability. If treatment's group yield was significantly higher than the control group, that means the difference is too large to be reasonably attributed to chance. Okay, so I don't think, if I was grading this, I'm not looking for something that looks like B. I really have no idea as to why they would phrase it in such a manner. I would simply say that the mean value of the treatment group and the control group, there is a significant difference between the two. I mean, 43 to 35, that's a difference of 8. So there's a significant reasons to say that, hey, applying the treatment BNF to the soybeans, it just helps them to grow. Okay, so or it hinders their ability to grow at a typical rate. So that's basically what it is. I think this is rate, its measurement of treatment to be compared to standard growing conditions and randomly selected the following that offer the bushels per acre. Let's see. So the bushels per acre means that we have that much that's the number of the bushels per acre of the soybean for each group. So since we're working to develop techniques to supplement crops so the BNF rate is not as greatly reduced. Okay, so the treatment allows for the BNF to diminish, which means it allows them to grow even significantly more. So therefore, I mean, resulting to their studies, I would say they're talking about this random variability. I haven't really touched that yet. So if you didn't say that, it's totally fine. The groups will probably be different. If the treatment group yield was statistically significantly higher than the control group, that means the difference is too large to be reasonably attributed to chance. So what that basically is saying is that, okay, so it's not due by chance. There must be something that's really attributed to not applying applying this treatment to help the bushels of acres of soybeans to grow. In some regards to that, that's what I was looking for. Okay, we can see the clear difference from the mean. Therefore, it's a good conclusion to say that this treatment for the BNF thing is working. Okay, sorry about B. This B answer is not something that I was looking for. Even if it was to say like that, I would say if whatever that you're also saying, it could probably also mean that it's significant, not due by chance. We'll go over that later when we talk about random variability though. The mean and the median would both decrease by, so the field workers report that the scientists and the machine measured to yield this treatment group was poorly calibrated. Each of the bushel values was over-reported. Over-reported means you need to subtract it. So each of the measures will be reduced. Describe the impact of doing so on the mean, median, standard deviation, and interquartile range. We talked about this, right? Mean and median would change. These won't. That's what I'm looking for. So the mean and median would both decrease by 0.5. So they tell you what it's going to happen, exactly by how much it's going to happen. They didn't really tell me why, which I really don't like. Just tell me a little sentence as to why that would be. That's because all the values decrease by 0.5. The standard deviation interquartile range would be unchanged. Why? Wow, this says the answer key, but this is not my type of answer key. I would really suggest, I don't know if the College Board people would like that. Maybe they will accept this, but they didn't say explain at the top of the question, but tell me why it would be unchanged. Some of you guys know what I'm looking for. So you can say that the deviation from each of the values would stay the same. The difference amongst the values stay the same, even though you add all the values to be higher. Since they're getting all added by the same amount, the difference will stay the same, somewhere in those regard. deviation remains the same because the difference among the points, or I'm sorry, not points, but among the data set does not change. That's basically what standard deviation is. It's a deviation from each of the data set. IQR is the difference between Q1 and Q3. They don't change. All right, we're down to our last question. A teachers union and a school district are negotiating salaries for the upcoming year. The teachers want more money, and the district, claiming as always budget constraints, wants to pay as little as possible. Wow, very applicable to me right now. The district, like most, has a large number of moderately paid teachers and a few highly paid administrators. Okay, so large number of moderately paid teachers. So if we're actually doing a pay scale, so this is like the average salary, and this is like the people who earn the most, and this is like the person who learns the least. We have a lot of people here and a few here. At least that's what they're talking about. The salaries of all teachers and administrators are included in trying to figure it out on average how much the professional staff currently earn. Which of the following would teachers union most likely to quote during negotiation? So if you're on the teachers union side, you want to fight for the teachers. So you want to not talk about these outliers. So what does not get impacted by the outliers? What's resistant? Median. Mean, no. These outliers pulls the mean towards in the favor of the administrators. The variance of all the salaries, I mean, look at the variance between the highest to the, to the moderately paid teachers. Standard deviation basically means same thing as the variance, okay? Interquartile range of all the salaries. Well, the interquartile range, well, technically speaking, they also have something to do with like, quarter one and quarter three. It's good, but it's not as good as median of all the salaries. That's like the measurement of center, right? Hey, a lot of people generally make about this much, but look at these people who's getting really paid extra for much or something like that. So that is what you want to say. Like, you don't want to say that at the end, but what the teachers are making versus what the administrators are doing, like how much they're making, median of all the salaries, that's the measurement of center you want to go for, because these are the outliers that we do not want to compensate for when we're talking about the entire thing. Okay. All right, so I think that's pretty much it here. So that should sum up the answers, and I'm hoping that this kind of gave you an idea as to what I'm looking for on all of the questions here. Let me know if you guys on the comments if you guys have any questions. If I made a mistake, please let me know. As again, 50 cents still apply here. So yeah, I think for now that should be it, and have a good night. Take care. Bye-bye.